So I'm here to talk a little bit about the potential of ChatGPT in a different area, in the health area. And I think there's an interesting question. Whenever we talk about ChatGPT, we ask ourselves, but what can it really do? What can it really empower us to do? Previous speakers here, and I completely agree, said that AI is not going to replace us, but maybe people who use AI might do a better job. So I think the question is, in different sectors, what can AI do for us? What can AI help professionals do? And we in Longevity AI have an ambitious goal. We want to get the help of AI. We want to be empowered by AI to give people healthy years. The question is, how can it be done? So since this is a convention talking about ChatGPT and AI, instead of showing you the regular slides of how we present ourselves, I want to directly deep dive into something a little bit more technical, but it's fully explainable. And I think it can be an interesting challenge to understand how can we take the opportunity of ChatGPT, the opportunity of AI, and look at a complex problem and find a simple solution. Because eventually, I think that if we ask people here, do we want to live a longer life as long as we're healthy and feeling good? I think all of us would love to say yes. So how do we even approach that concern, that problem that, we're aging, it's deteriorating, we're feeling a little bit less good, we're getting more chronic diseases. And the idea is how we can stay fit and healthy. So if you look at the evidence world, if you look at what we know right now from science, and first we need to take the data. Here we see on the left-hand side the raw data. On the right-hand side with the opportunities to help people living a healthier life. And in the center, it's going to be the center of our conversation is how can we leverage AI to do that solution? How can we leverage AI to help doctors? How can we leverage AI to help us, each and every one of us, to get insights from our doctors on living a better life? And eventually, how we get that system to work? How do we get the financial model to get this all working? Okay, so let's start. And by the way, this is a free for all conversation. If everybody have a question, sometimes I'm going to ask a question, feel free to jump in, all right? Okay, so when we're looking at the science today, and we're looking on the left-hand side here, we see all the opportunities to get data. So, right, if you want to train ChatGPT, also previous speakers talked about it before, we need a lot of data. So this is all the broad parameters that were ever proven to be connected to our health span, to us feeling better, free of disease. And these are all the genes. We have 73 ACMG genes approved by the American College of Genetics and Genomics, which is the clinical standard today, and 200 more genes that has a lot of evidence for people who want to be part of a higher tier of service clinical trial. We have a lot of wearable information. We're working with Apple Watch, connecting with Apple Health. And now we understand that a lot of the parameters that are coming from the wearables, it can be our steps, it can be how much workout we do, it can be how much sleep we have a big influence on our health. And doctors want to see it, and it's part of the decision-making. We have more information, we'll brief through it, microbiome, epigenetics, questionnaire, physical examination, and even the engagement. Because eventually it really matters. If we have a theoretical thing we want to do and we want to ask the AI, the ChatGPT, to help us understand what is feasible, it's not only the theory. Like previous speakers said before, it's a combination of computer and human. And here we need to also ask, what will the doctor would like to recommend? What will the user will actually be likely to do? So on the right-hand side, we see opportunities to help people. Lead a better lifestyle in realms of activity, in nutrition, in mind, in sleep, even in the rhythm. We have a 24-hour hormonal rhythm in our body, more sleep hormone in the morning, melatonin, more stress hormone in the morning, cortisol. And if we're sleeping regularly in the same hours and waking up regularly, we're more in sync. Another example, if we're not sleeping well at a specific night, the efficacy, the value of a workout will be less significant the next day, and we're more prone to injury. So we might want to reduce it. So left side, we see incoming data. Right side, we see opportunities to help. Now, as a data scientist, my favorite part is the center part. This is how it all comes together. And it's a question, how can we look at cardiovascular risk? Well, if you ask a classic heart doctor, they will tell you, well, we have the Framingham score. And if you ask him, do you like it? He said, definitely not. And if you ask why, they say, well, it's done 70 years ago in one village in the United States, not diverse ethnically, and 50% smokers, lower rates of diabetes and cardiovascular conditions. That means that is very biased, and it's still the world standard everywhere. So the first thing we're going to do, we have partnered here with a big HMO, with a big health infrastructure company and service company here in Israel called Maccabi. And what we're doing, we're taking hundreds of thousands of anonymized data rows of medical data. And we're saying, okay, this was done 70 years ago, but what about today? People today have different habits of smoking, of diabetes, of hypertension. Let's first take the classic data parameters, the classic algorithm, and adapt it to today. First, we see an initial better combination, initial better accuracy. That accuracy gives the doctor to understand, this is the needle mover. This is the medical biomarker that I can use to help the person reduce the risk of chronic heart disease. And what we did next, we took hundreds of parameters that are existing in the electronic medical records today, which are on the medical pathway of chronic diseases. And we know how to predict them better and how to prevent them better. Just for us to have a little taste of how the algorithm is based, we scrape all knowledge available on the web. We take only AAA evidence together with professors and doctors that we work with, and we map it and make sure that it's placed correctly. And unlike the classic golden standards, we adapt to different countries. You can see on the right-hand side, different countries. You can see this is for Japanese, and this is for USA, and this is for UK, and this is for Norwegian, different genders, different ages. And the doctors can always go and check and see that what the research is all about. So this is like the first layer of data. And this is the first layer that we're feeding ChatGPT. And to be more accurate, I think it's important to note, and also previous speakers talked about it, ChatGPT is being often used as a way to talk about large language models. It's like the family of the algorithms, where ChatGPT is an amazing tool. It's good for many different things. But as the example of Samsung, that the developers were giving a lot of code and now it's out there and people can somehow access some insights from it. In medicine, it's really important not to share anything with the web, even if it's anonymized data. So we use large language models, very similar to what ChatGPT is, and we apply them within the system. And this is a very similar way to implement ChatGPT style algorithm, but this time it's within the system, it's not connected to the external internet, and there's no privacy concerns. So I think that when we're talking about a convention about ChatGPT and large language models and generative AI, I think it's important to recognize that there are tools who are very commercial and more easy to use, like ChatGPT. And the previous speaker here really elegantly shown how we can easily implement it. And I think that it's a slightly bigger challenge, but it's a necessity in the world of health to take these algorithms and to close them in a closed box of this is the correct information that I'm feeding you, and you cannot talk externally. And this is basically what we see here in this diagram of us. Before I move forward, do we have any questions, any comments? All right, feel free if you have something. Now that we understood some of the computer science, some of the medical science, I think it's interesting to see, okay, how do we want to actually leverage this information? How can we possibly give people healthy years? It's a big question, right? So let's take a step back. This is how we show the doctors. This is how we're going to show the patients. We're going to get into it in a minute. First, I want to take a step back and understand, how does this industry even look like? So the world is getting older. The people above 65, thanks to modern medicine, has been significantly increasing, especially countries like the United States and China. But the challenge is that while people are living longer, the health span, the amount of time that we're spending disease-free is still remaining the same. And there's a gap. The gap is very painful for people with chronic conditions, with diseases, to their caregivers, the families, the countries, and also for the insurers, also for the medical insurers, the payers. They've cost, people with chronic disease cost 5 times more. So this is a problem that everybody wants to solve, and it's really painful. But how can you actually combat aging? So if you're looking what the CDC has mapped for us, then we understand that 80% of unhealthy years is just about 5 chronic conditions that we can predict early, like 5, 10, 20 years earlier by trends of biomarkers, and we can prevent them. We can give people more time without these diseases. And they accumulate to $3 trillion just in the US. Still a very big problem, but we're not sure how we can actually solve it. So if we're looking at how modern medicine is doing it today, it's before ChatGPT, before the AI revolution. AI was mostly in theory. 70 years ago, they made an algorithm that doctors can actually do by hand and calculate it by hand. It has these parameters here, and we can know, hello, John, hello, Guy. This is your risk for the upcoming 10 years of a heart condition. And it was done in the city of Framingham. And we want to do it differently. So you saw, I usually don't start like that. I previously showed you all the computer science and all the AI science behind it. And now you know, how can we make it more accurate? First of all, we just add more information that is influencing the parameters, that is influencing the conditions and the deterioration and aging in our body. We have the genetics, obviously, our sleep, our blood measurements, our steps, our microbiome. Everything has an influence, and luckily a lot of it, except for genes, can be influenced. Actually, depending on the condition and the person, between 70 to 90% of aging is in our hands. It's how we live our lives. And we can get AI to help us understand it. So when we're looking at the data, we understand it's not enough, because we have a theory. Okay, if you walk 2,000 more steps a day, you can reduce your risk by half, gain 5 extra healthy years. Everybody happy. You, your family, and even your insurance, all right? But easier said than done. We are all busy, we have families, we have our jobs. It's not like we can do everything tomorrow. So what we do, and this is very similar to ChatGPT with large language models, we understand the person. And we think that like YouTube and Netflix got to know you, got to know what you want in this moment in time, then we should expect the same from medical solutions, right? Why do we expect the medical solution to say every morning the same recommendation, every evening the same recommendation? Maybe on Tuesday mornings, I never do anything. Maybe I'm a new dad and I'm not sleeping, and on Tuesday I have something in the morning. And maybe I never want to change anything with my nutrition. I prefer something with sports. So a ping, a notification with nutrition, we're just going to get me, okay, you know what? I'm off the system. I don't want to continue. How do you create this continuous user engagement? So it's all about not only understanding the potential parameters we want to influence, it's understanding the person. So we know from your Apple Watch, John, that you loved swimming. So we're not going to recommend you running. How about running, or how about swimming once a week? So it's all about adapting in real time to what the patient wants, something more advanced. Maybe it's small changes, to drink a glass of water every morning. So what does it all mean? How can this create healthy years, right? We saw a little bit of the science, we saw a little bit about the problem. In reality, if we just help a person focus on one thing that can help them, that the doctor prescribed, we can change the trajectory of aging. We can take one chronic condition at a time, find the leading risk factor, and change it. And this is what we're bringing. We're bringing people the opportunity to do small changes in the lifestyle and gain this quality of life. So looking a little bit more about the technology, let's look about how we're building it. So first we have the medical opportunity. We're putting large language models, style ChatGPT, to look at electronic medical records, at genetics, at wearables, all starting from the golden standard and being more accurate with extra data. That's the basic line, because only medical solutions can move forward. If it's wellness, but has not yet been proven by evidence-based medicine, that's out. That's the only way to work with hospitals, with insurance, and gain everybody's trust. Second layer is financial. Well, we're dealing with cash boxes, what's called medical insurances. And if we look at them like that, they have an important role. They need to make sure that there's enough cash in the box. If we take, for example, France, we see that the situation is more money is coming out of the box than money coming in, and the government has to do something. So when we're recommending opportunities for improvement, we always make sure that it's worthwhile for the insurers. But luckily, every unhealthy year is really valuable not only for the individual, also for the insured. It's cost between $10,000 to $15,000 of unhealthy years. So the motivation of the medical insurer is really high, as long as there is a medical evidence. So a lot of solutions can move forward. And then I find it the most interesting part, the behavioral part. A lot of things work in theory, but it's all about understanding what this person would like to do right now. So again, we want to be the Netflix and YouTube, not something that's boring and gray and just monotonous. So we want to understand what types of things I am doing. If I'm a bit more stressed today, if I didn't sleep well today, how should it adapt? It should be understanding me in real time. I should trust it to know what I feel like doing. And eventually, like we know all the solutions that we love to use, it will learn us and adapt to us. And this is the beauty of large language models. So it can create a lot of intuitive solutions that data scientists like myself or like people here in the team can do small tweaks, but get a lot of value thanks to the sophistication of these large language models. This is the gist of it. I'm going to leave some room for questions. You can ask me anything regarding how the algorithm is built, why is this data more important or less important, and how come we think that this can actually bring healthy years, right? All things which are very important to us here at Longevity AI.
Thank you so much, Guy, for the insights on the healthcare aspect of generative AI. So now we are open for Q&A session. If you have anything to ask, you can ask. I think we have a question here, yeah, in the chat box. So I think it's Nilkant. He's asking, how do you capture data in real time?
Okay, that's very interesting. So first of all, we understand the value of real time, because if it's not adapted to me in real time, I'm just not going to do the recommendation, right? So the value is clear, but how do we solve it? So we have several opportunities. While electronic medical records are only adapted when we go to the doctor and when we do a blood test, can be every few months, every few years. The wearable is updated continuously, and data scientists, this is their bread and butter. This is what we love the most. So we can know about the steps. Am I walking more in the morning, in the evening? Did I just walk up the flight of stairs? But what if you don't have wearable, right? Not everybody wants to wear it. Maybe they wear it, but not at night. So the phone can suggest a lot of information while connecting with API to Apple Health or Google Health. For people with Android, we can extract a lot of information. Steps are still recorded in the phone. To some extent of accuracy, also sleep. But if you want to bring it to the clinic, we need a wearable for the sleep. So it's always a combination with IoT, with devices that we have that record in real time, and we can give in real time. One of my personal favorites, also Tim Cook has it, continuous glucose monitoring. It's really important for our health. It's very trending right now. And basically, we get more glucose in our blood, unfortunately, as we age. And it's important to monitor it. And it's important to personalize the foods that we eat, what spikes it. So there's lots of opportunities. And I think the key for the algorithmic part, if we're taking it back to ChatGPT, large language models, what kind of information we're bringing in, it's important that the architecture of the algorithm will be modular. Some people will have wearables, some people have only phones.
So on to the next question. We have Mohammed from Dubai. He's asking, what about privacy of data in generative AI?
That's a very important question. When we're talking with health providers, they find it crucial to understand the policies. First, from a regulationary point of view, you have HIPAA in the States, GDPR in Europe, and they give us the standards that no information can ever be shared on the internet, okay? That's true for identifiable information, which is very important to keep in a very separate area. And it's also important for anonymized information, which is what we do in Longevity AI. the algorithm does not find it useful to understand that my name is Guy, but it does find it useful to understand how many steps I did. So first, we de-identify all the information. We never collect information that tells us who that person is. But still, this is not enough. According to regulation of medical institutions, it's important not to use ChatGPT, the classic version. It's important to take large language models, which are offline, closed in a box, okay? It's called a virtual private server. They cannot connect to the internet. Only information can come in about the patient, and conclusions can come out in a regulated way. So this is the way to deal with privacy and security, and this is key with any collaboration you want to do in healthcare.
The last question for you, Guy. It's from Martin Petkov. He's asking, do you see the potential to integrate real-time biofeedback? In terms of numbers of quality years, how many do you think can be added to a person's life with positive changes introduced in mid-20s?
Martin, so I see you're knowledgeable in longevity and the potential to influence. So indeed, a great to the point question. I think that it's not by accident that maybe he asked about 20 plus, because most of clinical evidence are by 18 plus people. So this is also what longevity AI is focusing on. And it's not a random choice. This is what the industry is leaning towards. And we were talking about quality years, or how the WHO is referencing as qualis, years that we're feeling independent, disease-free. It really depends on the person, on the genetics, but it's mostly up to us. And we can get, with today's medicines and solution, 10 to 20 years. And when we're looking at upcoming solutions that are supposed to be fruitful in the next 2, 3, 5 years, example with epigenetics, we're a big believer in. So this can even extend to extra 50 or 70 healthy years. But this is technology that has not been proven in humans yet. But if we're using it today, and we want to live a healthy life, and we're willing to do small changes to our lifestyle, and we're willing to communicate with our doctors about it, then we can gain 10 to 20 healthy years. And I think that's a big motivation for many people.
Well, I guess that's the end of questions for you, Guy. Thank you so much.
Thank you very much for having me. It was a great pleasure.
Thank you so much.